Hello everyone and welcome back to the DAO Adventure. My name is Sebastian, I am Education Lead at Golden State and I'm here to help you build a DAO on the internet computer in 7 days. Today we are building project 2 out of 5 from the DAO Adventure and this is about building your tribe. So if you're not familiar with the DAO Adventure, we have 3 phases: initiation, training and graduation. We are right now in the training phase. The training phase is composed of 5 Motoko projects where I guide you through the code. Those projects are optional but recommended. The goal is to get you ready for the graduation. In the graduation, you build and deploy your own DAO and you can earn your Motoko Bootcamp Diploma. Alright, so let's jump into today's mission. Our mission today is to build a database for our members. So we want members to be able to join, to see their profile, to update their profile, and also be able to delete their profile. The idea is that a DAO is primarily a community organization, so you need other people able to join your application, and so we will implement that as a database in our canister. As always, you need to jump to the DAO Adventure training repository, and you can open either locally or you can open directly in your browser by clicking here and opening in Gitpod. As always, I have my Motoko file on the left and my project.md, project.markdown file on the right. Project 2, building bonds. After a few days at the academy, you realize that the power of the institution is not in the code or books, but in its people. Everywhere you look, you see students having intense and passionate conversation. Some students are even brainstorming and coding together. The atmosphere is electric and you can feel the energy in the air. You quickly understand that to thrive in this environment, you need to build bonds with your fellow students. You need to build and find your tribe. Your mission is to make it possible for your fellow students to join as members of your DAO. You might not know it yet, but you need them if you want the DAO to evolve. Those are the requirements for today. Anyone is able to join the DAO and create a member profile, which we will define. Users are authenticated and can only modify their own profile, so we will need to implement an authentication system. Members can leave the DAO by deleting their member profile. Those are the tasks. To help us get started, we have defined different types in main.motoko, a new type member to represent the members of your DAO. So this is an object that we have defined, a new type that is defined in actually a file that we import, which is the type file. If you look at here, you have main.motoko and also types.motoko. In types.motoko, you have the result type, the hash map type, and this member type, which is a custom type. So this one is the one that we've created ourselves. It's an object with 2 records, 2 fields, name of type text and age of type natural number. A new type result that we've imported from the result library. This will be used to return potential errors. Type results, okay, error, result.result. So this is one that we've imported from the results module. We will talk about that later. Same, we also have a type hashmap that we've imported from the hashmap library. This type will be used to store the members of your DAO. Okay, so it seems that we have to use hashmap, result, and member, and we have to follow the task. As always, we have a few tasks to define variables, implement some functions. We have 7 functions to implement today. And at the end of this level, at the end of this project, your canister should implement the following interface: add member, so you can take a look, add member, update member, remove member. So those are all the methods that we can see here: add member, update member, remove member, get all members, number of members. All right, so this is time for you to pause this video and to try by yourself to complete the project number 2. You have all the information that you need in the results library and hashmap library, and also by following the task, you should be able to implement those functions. Good luck, and I see you in a few minutes for the correction. All right, we are about time. I'll process to the correction now. I hope that you've successfully implemented those functions. Otherwise, don't worry, I'll correct and explain everything. So the task number 1 was to define an immutable variable members of type hashmap principal member. So what does it mean? Hashmap principal member. This represents the key and the value of your hashmap. So an hashmap, if you are not familiar, I'll provide a link in the description to a video explaining what is a hashmap. But essentially a hashmap is a data structure that associates keys with values. So for example, you can store users of type member and associate them with what's called a principal, which is an identifier that is unique to each member. And if you have the principal, you can access the member. You could also have key of type not and value of type text. You could store, for example, a post, and each post has an ID with a type not, and you can, knowing the ID, you could access the post. The type hashmap is explained in more details in the hashmap module from the Motoko base library. Hashmap is implemented as a class with keys of type K to values of type V. You can also read the explanation on how the hashmap is implemented, and if you're interested, you can also dive into the source code where essentially the hashmap class is created. What we need for today is how to define hashmap. So it seems that we can define a hashmap with the initiation function here. We need the initial capacity, which is how many elements can we store in the hashmap originally. We need this function key equal. This is a function that takes two keys and returns a boolean indicating if the keys are equal or not. This is necessary for the internal working of the hashmap. And also we have this key hash, which takes a key and returns a hash. A hash is essentially an alias for a NAT32. So type hash is in the hash module is a NAT32. Essentially a hash is used internally by the hashmap. So we need to find a way to transform, in our case, two principles for the key equal and one principle for the hash. The initial capacity, we can set it to 0, 10 or 100. It's essentially going to grow whenever we need more capacity in the hashmap, so we don't need to worry too much about that. Okay, so let's see the exact code. So let members equal hashmap dot hashmap. Yes, you need to make sure that you have a capital M, because here I'm importing from hashmap and the capital M is important. It wouldn't work if you use this one. So make sure that you have a capital M in your hashmap if you have named your module like this. Of course, we could also do this, or we could even do that. But I prefer to keep the same names here and here. So hashmap.hashmap, initial capacity. Well, first we need to define the type of the key and the values. This is important. So the key are of type principal and the values are of type member. The initial capacity will be 0, and then we need a function on the keys and a function on the key. The first function will be the equality function, and the second function will be the hash function. Fortunately for the principal, we have principal.equal and principal.hash that we can use. So how can you find out about those methods and how could you know about that? Let me show you. So of course we need to import principal module. Motoko has a principal module, which essentially contains functions that we can use with principles. One of the functions is principal.hash. This function takes a principal of type principal and return hash.hash. So it returns a hash, essentially. This is exactly the function that we need. If you remember the hashmap module, we need to find a function that takes a key. So in our case, the key is of type principal and return a hash. So exactly this function would work. And the second one is principal.equal. This function takes two principal. So it takes a tuple of principal, principal 1, principal 2, and returns a boolean indicating if principal 1 is equal to principal 2. If you remember, this is exactly what we need. This is the type. This is the function type that we need. Key equality takes two keys, so two principal, and return a boolean. So that's how we complete task number 2. Now that we have the hashmap, we will be able to use it to add member, get member, remove member, and so on. One question that I've often heard is, why do we define this as an immutable variable? Because we are using let here. When we want to actually be able to add member, remove member, and so on, because we will, of course, modify what's stored inside the hashmap. The answer is that hashmap is implemented as a class, so we will never actually reallocate the variable. So we will never do members reallocated to another data structure. we will directly do members.put, members.add, member.get. And so this is not the same as changing the variable. So we are not changing the reference to the variable, we are changing the content within the variable. So if you want more details, you can read the explanation that is here. Now the second task is to implement the add member method. This function takes a member, so here, of type member, adds a new member to the members hash map. The function should check if the color is already a member, so the color is specified here. If that's the case, use a result type to return an error message. So we have three new concepts here. We have the color concept, we have the hash map concept, and the results concept. That's a lot of new concepts. I'm aware of that. If you are not familiar with either result, color, or hash map, please watch previous videos. There will be explanation about those topics. But just so you know, for this project, the color is essentially the principal of the person calling this method. So if it's me from the FX, it's going to be my principal. But if it's a user from an interface, or if it's some other canister that is calling this method, we will receive the principal of the color as a color argument here. And result is a new type from the Motoko base library, which I will show you right now. There is a module called result that is used for error handling. So type result contains a OK type and error type, and a result is a variant. So a variant is a type that is either this one or this one. So either this is OK of type OK, or error of type error. Essentially, this is used to specify a return and propagate potential errors. And here our OK type is the unit type and our error type is a text type. So essentially, if this function is successful, we want to return OK without anything inside the OK. If the function doesn't work, so for example, the color is already a member of the DAO, we want to return an error message just like we are doing here. Error message, the color is already a member or something similar. And maybe we have other error message that we can send. For this function, we will use the hashmap.put method. So hashmap.put takes two parameters, the key and the value, and insert the value with the key. If there is already an existing entry, it will overwrite this entry. This is why we need to verify that the color is not already a member. Otherwise, we would be able to rewrite the member profile, and that's not something we want. First thing we want to check is the member inside the hash map? So is there essentially a member that is associated with the principal that is calling us? And for that, we can use hashmap.get. So hashmap.get returns the value associated with the key, if present, otherwise return null. And so we can see that the return value is optional. Whenever we have a return value that is optional, so essentially optional meaning if there is a member associated with our principal, so if there is a member associated with the color, we will return the member. If not, we will return the null object. So the null object, the null value is a specific value in Motoko that represents the absence of value. And so an optional type is here to indicate that the return type of this function is optional, meaning either it's going to be of type value, so of type member in our case, or it's going to be null. Whenever you have an optional type, you can use switch case to differentiate between the two cases. So if I do switch members.get color, I can use that to separate my code into two specific contexts. The first one will be case where the return value is null. So essentially there is no member associated with our principal. In that case, we can do members.put with the key would be color and the value would be member. And then we can return OK. In the case where there is a member and we need to write it like this, so optional member, the syntax is always like this because it enables us to essentially access the member in this context, in the following context in Motoko. The member will not be this variable anymore. So here I could also say old member just to differentiate. Here I can access all member, and all member represents the member that is already inside the hash map. In our case, we don't really need this variable. We just need to return an error indicating this principal or your principal is already associated with a member profile. So essentially, we are saying to our user, the one that is calling us, you are already registered in our DAO, so you don't need to call this function again. So we've implemented task number 2. Now we can move to task number 3. Task number 3, implement the getMember query function. This function takes a principal. So this time our principal is in the argument. It's not specified as the color, is the argument. And returns the corresponding member. You will use a return type for your return value. So essentially, we will see if there is a member associated, and if there is, we return it. If there is not, we return an error message. So this is very similar to what we've already done. I'm going to move this function up here just to respect the order. And I'll use a switch case again, because we are working with optional value. So switch case is the way to go. Members.get, this case, it's going to be P, the principal that is specified here. In the case where we have no member, I will return an error message, return error, and then I can specify the message within the parentheses. There is no member associated with this principal. I could even specify the principal. So we could do that with using principal.toText, which is a function from the principal module, and using the concatenation operator. So this operator essentially concatenates two texts together. In the case of a member, I will return the member directly. So return OK, and inside I can return the member. So this time, this is of type optional, but this one is not of type optional because we are using the switch case, so we are able to unwrap the optional type. So here, when we're using members.get, we are getting back an optional member, but in this case, we are getting the member unwrapped. So there is no optional. As you can see, it's not an optional member, it's an actual member. Let's work on function number 4. Function number 4 is about update member function. So this one, we want to take a member of type member as a parameter and update the corresponding member associated with the color. If the member doesn't exist, return an error message, and you will use a result type for your return value. Essentially, it looks like this is the opposite scenario of add member. We want to essentially return an error message if the member already doesn't exist. And if the member already exists, we want to change the member object that is stored in the hash map. So let's get to work. We will also implement a switch case in that scenario. Switch, and so this will be members.getColor. In the case null, so we don't have any profile, this is where we will return an error. There is no member profile associated with your principal. Again, we can return the exact principal by using principal.toText of the color. In the case where we have a member, so this is how we get the member, and this is, we will name it old member just to avoid confusion with this variable. We will do members.put color and member, so the new member essentially, and then return OK once we have modified our hash map. And we are good with function number 4, so that's task number 4, update member. Task number 5, implement the getAllMembers query function. This function takes no parameter and returns all the members of your DAO as an array of type array of member. So we are talking about this function. We have an array. So for this function, we will need to iterate over our hash map, and we need to take a look at the hash map library. We have what's called as iterators. Iterators on the keys, iterators on the values, iterators and on the entries. So an iterator of type iter enables us to essentially loop over the entire hash map. We can do that for the keys, so we will loop over all the principles that exist. In our case, the keys are type principal again. We can do that for the values, so we will iterate over all the member. This is probably what we need to do here. And finally, we could also iterate over the entries with dot entries. The entries would essentially be a tuple with the first index in the tuple being the key and the second index being the value. In our case, we want to use dot values because this is what we are looking for. This is the members that we want to loop over. Also, we can take a look at the iter module. So iter is also a module from the base library. And in the iter module, we have a function called toArray, essentially consuming an iterator and collecting all the producing elements inside an array. So what we want to do is creating an iterator that will iterate over every member in our hash map and then converting this iterator to an array. We can do that by running the following command. So our iterator will be, let iterator is going to be members.values. We'll iterate over all the values. And then we can return, not like this. We can return iter.toArray over iterator. And this will return an array of member. Of course, we need to import the iter module in our code. And now we are good. We could also simplify the code simply by changing this line and directly using member.values. All right, we are good. Implement, so this is our next function, implement the number of members query function. This function takes no parameter and returns the number of members of your DAO as a natural number. So we are simply looking to calculate the number of value in our hash map. What we could do would be to create a count over the iterator, and we could count how many members we have. But actually, we also have an easier method that is directly in the hash map class implemented. It's actually the first function, hashmap.size, returns the current number of key value entries in the map. So essentially, in our case, it will return the number of member because we would not have any member that is not associated with a principal. So essentially, the number of key value entries is the number of members. So we can move this one a little bit higher and then return members.size. And that's it. We are good. Finally, our last function, task number 7, implement the remove member function. This function takes no parameter and remove the member associated with the color. If there is no member associated with the color, return an error message. Again, we will need to use a switch case, and depending on if there is a member associated with the principal of the color, take different action. So if there is not, this is a simple case. We can just return an error, and we can actually copy our error message from previous function. So we can copy this one. And in the case where we have a member, we can use a new method called .delete. Delete the entry with the key, key. So the key that is passed here. Essentially, we can do members.delete color and it will automatically delete the member associated with the color, and then we can return OK. We could also use the dot remove, but dot remove also deletes the entry but returns the old value. So in our case, we don't really need to access the old value. Maybe we could return the old member profile, but this is not a requirement of this method. But just so you know, you have members.delete and also members.remove. All right, so that's it for the project number 2. Now I will move to the deployments. Again, I'll deploy in the playgrounds, and this project is called project 2. Testing this project in the Candid UI will be slightly different than what we are used to, because as you've probably noticed, and I've explained during the code, we are using this color argument that comes from the principle that is calling us. When you are using the Candid UI and you are not logged in, you are using what's called as anonymous identity. Actually, I can show you the anonymous identity here by simply adding a whoami function. So public shared color function whoami, and it will return a principal which will be just returning this color argument. Now I can deploy again. Which would be project 2. And so because we are using the anonymous identity, you will only be able to create one member, then get this member, remove this member, but you are not able to perform tests for multiple identities because you would need to change your principal. So you will need either to log in or you will need to use DFX. With DFX, we can actually change identity. I will show you that, but before I'll show you the principle of the anonymous identity. So this is the principle of the anonymous identity. This specific value is the same for any identity that is anonymous, which means that we are not logged in. This is an important value that you need to keep in mind because you will probably see this principle in a lot of cases. Now, if you're using DFX, you can use DFX identity list to move between different identities. So right now we have the default and the anonymous. So we could move to the anonymous. I would show you the principal by running DFX identity get principal. And as you can see, this is the exact same value that the one we have from the Candid UI. But we could also create new identity by running DFX identity new. We can call that test1. You can enter a passphrase, so I'll go with a simple one. You can do test2, simple one again. If you don't want the passphrase, I think that you can do DFX identity new, test3. And storage mode, plain text. And yeah, you can use this identity without a password. And then if you look at our list of identity, we have new identity, and we can use those identity by running DFX identity use test1. And now if you do DFX identity get principal, you have a different principal for each of them. So this is our identity 1, and I'll show you that with identity 2, we have a different principal, another one, and for identity 3, it will be the same. We have a different principal. So we could use this identity to call our canister. For example, we could call the DFX canister call project 2. So we need to specify playground call project 2, and we could call the add member method. So add member method, we will need to specify the member as an argument. So the member is an object. We need to use the Candid syntax in the DFX command line. So here we are using the Candid interface, and so we need to specify record and then the members field. So we need to take a look at the types.motoko file, the name, which would be, in my case, Seb, and the age be 25, and then you can close this, adding a semicolon here, and close the arguments. And as you can see, I have this OK that is returned, so I have been able to add a member. If I try again with the same identity, it will tell me that my principal is already associated with a member profile. But if I change and use another identity, so right now I think I'm using test number 3, so I'll move to test number 2, and I try to add maybe a different identity. This time it will work because I'm calling with a different color. But if I try again after being added, this time it will fail. So you can use the FX to create multiple identity and do your tests with the FX instead of using the Candid UI. Of course, we could also use the Candid UI. We should receive correct information. At least we should receive number of members should be 2. If we call the get all members, which is here, we should see our information. Those are public information. Of course, we could choose to hide that information in a real DAO. We maybe don't want to let everyone call this method. And we can also add a new member from here. So with the anonymous identity is able to add a member, but only one, just like any other identity. So if I try to call again, this will fail. And I can use the whoami method to receive my principal and then copy this principal in the get member and receive my member profile as an answer. And that's correct. All right, hope you've enjoyed this project number 2. This project number 2 was really important. We've implemented a CRUD application. So CRUD meaning create, read, updates, and delete. This is the fundamental of many applications. And so you can imagine that we can do that for members, but we could do that for posts on a social media, for NFTs, for tokens, all sorts of purposes. Don't hesitate to watch this video again and also previous videos where I explain the principle, result type, hash map, tree map, and the switch case optional types. Those are important concepts in Motoko. You really need to get those concepts before moving to more advanced topics. See you in the next video, and in the meantime, keep building.